Welcome to Math with Mrs. Cartwright. So today we are talking about functions. We're going to be using graphs to relate to quantities today. So we're starting it on our graphing units. All right, so key concept that we are going to be able to use graphs to, or can use graphs to visually represent the relationship between two variable quantities as they both change. So here's an example of what we're talking about. So the graphs below relate the height of the water to the volume of the water in each container. So our x value is volume and our y value is the height in the container. So which graph goes with each container? And then we justify our reasoning. So the amount of water that I put into each of these containers, and then versus how tall it is in each container, graphs differently. So if I put like a cubic inch of water in each of these, well, a cubic inch in this first one, because it's so wide, isn't going to be very tall. Whereas a cubic inch in these other two are going to be about the same height. And so knowing that, because they start off as that same cylindrical shape, knowing that, I know that this first one is going to be this one down here. And I know that because these other two kind of have that same start off, right? That they're increasing pretty quickly. So I know that this shape here matches with this graph here. The other thing I know is that no matter how much, like if I add, another cubic inch, it's going to just increase by the same volume, like the same height. And it's because it's a wider shape, the height of the water is not going to drastically change each time. Whereas on this second one, it's going to drastically change, but at a constant rate the whole time. And then this third one, up until we hit the funnel-like shape, once we hit the funnel, it'll start to slow down on our height. And the reason is because our funnel gets wider. And so thinking of that, the one that has the constant quick rate of change would be this third graph. So that's what I'm going to match with this second cylinder. And then that means that this process of elimination, but also we rise pretty quickly because of the skinny cylinder shape. But then our volume, like the more volume we put, the height doesn't grow as fast once we get to the funnel shape. So those are things that we're talking about in these lessons. All right, so example 1, analyzing our graph. The graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables, and describe how the variables are related at various points in the graph? So let's start with that first question. What are the variables? Well, because we should always restate our question in our answer. Our variables are time, because that's our x variable, right? Time and volume. So those are our variables. So we're talking about air in a balloon as we blow it up. I know that by the title. I know it because it says it here. And so now I'm going to look at this graph, and I notice that we increase and then we stay the same, and then we increase and we stay the same. So this is what we'd call, and for increase, this is what we call constant when we don't change. Constant. That's this piece here. This one here is another increase. And then here we have another, I'll put C for constant, and then we have an increase, another constant, an increase, and then a very drastic decrease. So if we think about blowing up a balloon, right? Try that again. when we think about blowing up a balloon, we take in a deep breath and then we blow it into the balloon, and the volume of the balloon would increase. And then if it's not the size we want it, we're going to pinch it off as we take in a breath to then blow into the balloon again. So if we think about it, the volume increases each time I blow into the balloon. It stays the same as I take a breath, and then it increases, stays the same. I blow into the balloon, I take a breath, I blow into the balloon, and what would be the one thing that makes it drastically drop to zero? And that's the fact that the balloon dropped or popped. So describe how the variables are related at various points in the graph. Our volume increases each time we blow into the balloon. It stays constant when we pause for a breath, pause to breathe, and then on the fourth, right? 1, 2, 3, yep, fourth blow, the balloon pops and volume decreases to 0. Now, words that help us describe our graphs would be words like increase, constant, and decrease. Those are the three things that can happen to our graph. Like we're increasing either in speed, here we're increasing volume, right? Or we decrease, or we stay the same. Constant just means stay the same. Those are the three things that can happen in a graph. All right. In the next, actually, we're going to do this last one, and then we'll put the next one on its own. All right, so example 2. A band allows fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? All right, so first thing I notice when looking at the table is that our values increase. So when I look at the graphs using process of elimination, D decreases. So it can't be D. So I'm looking at these others that are increasing. Now, to know whether it's constant or a more substantial increase than what we have, then what I'm going to do is I'm going to take 1011 minus 346. And when I get that, or when I do that, I get 665. Now, if it's the same for all of these, if it's the same number for all of these, then I want this straight line. If it's not, then we've got to make a decision between these other two. So now I'm going to take 3,455 minus 1,011, and I get 2,444, which is not the same. So because it's not the same, we're going to take out A. Because it is not the same 665 each time. All right, and then so that I can compare the way we're increasing, I'm going to subtract these as well, and I get 6,971. And so I increase a lot, and it keeps getting bigger. So the difference between these two is like this starts with a subtle increase and then gets to be a steep increase, whereas this starts pretty steep and then settles off. Whereas, so when we're looking at our numbers, we're starting not so far apart and then getting really far apart. And so that's why it's not C. C starts really far apart and then gets closer, whereas B starts pretty close and then gets further apart. So our answer for this one is B, and there it is. I'm like, on my screen, I lost it. And that's how we can use process of elimination to help us match our graphs, just like you will most likely have to do on your homework. So until next time, later, 8th graders.